When we start talking about a gas, it's important to talk about the pressure of a gas. And, well, what is pressure? Pressure is the force exerted by an object over a certain area. And how does this apply to gases? So in the same video I showed you before, we'll watch as the gas particles move. And every time that one of these gas particles hit the side of the container, it exerts a force. The greater number of times that these particles hit the sides of the container, the more pressure they're going to exert, the more force they are going to exert. So for a gas, the more collisions there are in a given amount of time with the sides of the container, the higher the pressure. So pressure is a measure of how often the gas particles hit the sides of their container, or of the container. Well, how do we measure pressure? Well, there are several units, just like in temperature, that we can use, and the main one that we use is the atmosphere. And this is abbreviated ATM. And 1 atmosphere is the pressure at sea level. So on average, 1 ATM is the pressure at sea level. It fluctuates a little bit, but that's what it normally is. We also have a few other units. We can also use millimeters of mercury. And this is abbreviated mmHg. And the unit millimeters of mercury comes from when barometers use mercury, a liquid metal, to measure pressure. In a mercury thermometer, the air, the atmosphere, is able to push down on this exposed mercury. So this is open to the air. And when the air pressure increases, the mercury is forced up higher in the tube. And when the air pressure decreases, the level falls back down. Atmospheric pressure, so 1 ATM equals 760 millimeters of mercury. And that's also equal to one other unit that's also used, 760 torr. Torr and millimeters of mercury are very similar, so notice that atmospheric pressure, 1 atmosphere, is equal to 760 millimeters of mercury, or 760 torr. The last unit that we're going to talk about here is the kilopascal, or kPa. One atmosphere is equal to 101.3 kilopascals. And it's just another unit that's used, and it can be the kilopascal can be actually derived from newtons and force. So those are the common units. And what's nice is it's very easy to convert from one to the other. So let's say I have 4 atmospheres. And I want to convert that to millimeters of mercury. Well, my conversion is exactly the same as I would do for stoichiometry. I have my given 4 atmospheres over 1 times new fraction, old unit on the bottom, new unit on top. Well, 1 atmosphere is how many millimeters of mercury? Well, 1 atmosphere is 760. And I do this out, ATM cancel out, and I get 3,040 millimeters of mercury. And that's really all there is to converting pressure units. If I have a case, let's look at one more problem, where I have to convert 800 millimeters of mercury, and I want to get that to kilopascals. Well, I don't have a direct relationship there. So what do? 800 millimeters of mercury over 1 times, so millimeters of mercury will still go on the bottom. And I don't know a relationship between millimeters of mercury and kilopascals, but I do know one between millimeters of mercury and atmospheres. So I'll convert to atmospheres. And then I'll need another fraction. Atmospheres on the bottom, kilopascals on top, because I do know that relationship. Cancels, cancels. 1 atmosphere is 760 millimeters of mercury. 1 atmosphere is 101.3 kilopascals, and I solve to get 106.6 kilopascals. And just so you know, the most common unit that you are going to see in chemistry is going to be the atmosphere. This is the most used one, so oftentimes you will have to convert to the atmosphere from some other unit.